Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, it's been a few months since we've talked OCS-I, but we're going to rectify that today. Here's today's topic. OCS-I update. Now, there are a couple of reasons why we chose OCS-I for today's topic. First of all, there's been a lot of development and a lot of new additions to the product line. And secondly, we've got a promotion that we thought we would tell you about. All right, let's get right to it and break down today's topic. Okay, we're going to talk about what is OCS-I, giving you a little bit of a review, talking about where it fits in the Horner product line. We'll give you plenty of technical details on all the modules that are available, including the recent additions. We'll take a little bit of a break and show you some of the ins and outs of the mechanical package, the assembly procedure, removing terminals, those sorts of things. And of course, we're going to talk about the products that are on the way, not quite available yet. And then we're going to go through that OCS-I promotion that you might be able to take advantage of. All right, here we go. Okay, so what is OCS-I? Now, it is a family of expansion and remote I/O that will complement any Horner automation control system. Now, the slide says it's new, and it is fairly new, but it's been out for a couple of years now, and it's really gotten off to a great start. So, frankly, this is our primary I/O system these days. Now, OCS-I is a ground-up design. So, we did not design the mechanical package. So, the plastic and the terminal blocks, we didn't design those. However, all the electronics, all the firmware, all the software, everything about OCS-I except for the mechanical package is a Horner design. And it's a design that is fully integrated into Seascape and will work well with any OCS. Now, OCS has been designed, or OCS-I, I should say, has been designed to work equally well whether you're using a canvas controller, which is the Horner top end of the product line, or whether you're using the micro OCS, which is our entry-level product, or it could be anywhere in between. Maybe the Prime series or the XL series is what you're using. OCS-I can work really well. Now, one of the things unique about OCS-I that we're going to talk about is the fact that you have the ability to buy a base, an I/O base that has some built-in I/O. That's pretty unique. And in addition to making it great for, smaller I/O systems with that little bit of built-in I/O on the base, it also is highly expandable and works really well as a larger control system. And once again, OCS-I is the primary offering for I/O these days from Horner. We haven't obsoleted any of our other I/O products, but this is really the I/O family that we are putting all the development efforts towards the future. Okay, so how do you connect OCS-I to a Horner OCS? Well, basically it connects over CAN, okay? And it's really just a plug-and-play operation, very easy configuration from the CAN connection on the OCS, whether you're talking about the RJ45 CAN connection on a micro OCS, or whether you're talking about the open style terminal on, say, Canvas or Prime. The CAN port on your OCS connects to the base, and the base features RJ45 in and RJ45 out. So if you're using micro OCS, you just use a patch cable to connect the micro OCS to OCS-I. If you're using one of the OCSs with an open style terminal for CAN, then you can either buy a cable that's been pre-assembled for you that goes from the open style to RJ45, or you can very easily build your own. So that's the connectivity physically between the Horner OCS and OCS-I. Now, you can very easily connect multiple bases for a highly expandable I/O system if you have a large I/O system. And if you're talking micro OCS, it's just a matter of patch cables and daisy chaining everything until the last base, and you have a terminating plug that would be installed at the end of the line. That's shown there at the bottom. And if you're using, of course, Canvas or Prime, the only difference is that initial connection from the OCS to OCS-I is that RJ45 to open style connector. Everything else, if you have multiple bases, is just RJ45 patch cables. And of course, you still have that terminating plug at the end of the line. Okay, the I/O connector where all your field wiring is connected. Here's the details on that. It is spring clamp style. All positions are labeled so you can see very clearly where on your print your wire needs to connect to the module. Okay, and there are two different terminal blocks that are used, a 6-pin and a 4-pin. You can see the specifications there. And we are recommending that you use ferrules, because if you use ferrules, then you don't have to use tools for inserting your wires, for instance, just for removing wires if that becomes necessary. Another thing to keep in mind is there's no reason to use overly large wire with OCS-I or any other I/O wiring, for instance. 18 gauge wiring has plenty of ampacity. It's very easy to work with. Again, if you use it with ferrules, and we recommend the slightly longer 10 millimeter barrel style ferrules for use with OCS-I, then it makes things really easy. Again, you don't need tools for wire insertion, only for removing wires if you need to. So when you're building up an OCS-I system, it starts with an I/O base, okay? And we've kind of highlighted the different aspects of the base, from LED status at the top, letting you know everything is working well, to the connectivity of C-scan with the RJ45 in and the RJ45 out. At the bottom front there, you can see that's where the screw terminals are. They're not really screw terminals, they're actually spring clamp terminals for connecting power, as well as some onboard I/O for one of our I/O bases. We'll go into more detail with that in a few minutes. And there's a backplane connector on every base, and ultimately also in every I/O module that interconnects everything so that the base can talk to all the modules, and then ultimately the whole system talks back to the OCS. Let's start with that first base that has built-in I/O, because this has some real usage for applications where you just need to add a little bit more I/O to your I/O system, especially, let's say, if it's micro OCS. So what are the I/O points that are built into the CNX 116 base? Well, you get two flexible inputs, which can either be digital DC inputs or analog inputs, 4 to 20 milliamp or 0 to 10 volt. You also get two DC outputs that are pretty beefy at 2 amps each. You get a universal analog input, which is 16-bit in resolution, so very high quality there, 4 to 20 milliamp, 0 to 10 volt, RTD temperature sensor, thermocouple temperature sensor, or maybe a millivolt signal. All those are supported through that universal analog input. And then you also get an analog output, 4 to 20 milliamp or 0 to 10 volt. So again, if you just need a little bit more added to your control system, it's very possible that the I/O that's built into the CNX 116 base may be all that you actually need. So in the case maybe of a micro OCS system, again, maybe you just need to add, you've got some other analog for pressure and things, and you want to add a high quality temperature sensor, maybe a thermocouple or an RTD with high resolution. Maybe you want to add an extra analog output, or maybe a couple of 5-volt DC inputs, because the flexible inputs have a flexible on and off threshold as well. So again, you can add that flexibility through a single module, if that's all you need, to a micro OCS very economically. Now, if you need more I/O than that, whether you're talking about a micro OCS system or a canvas or anywhere in between, it's very easy to build a rack starting with a base, whether the base has built-in I/O or not, and then you can add an additional 7 modules to that base, and the next thing you know, you've got a larger I/O system. Now let's go through the available products in the OCS-I family. We've already talked about the CNX 116 base that has the built-in I/O. Now let's move our way through the rest of the product line. All right, let's start with another available base, the CNX 100. So with the CNX 100, there is no built-in I/O. It just provides power for the rack along with the connectivity to the OCS through the RJ45 in and the RJ45 out. First of all, this is useful if you really can't take advantage of the 6 extra I/O points in your application, or maybe if it's a retrofit application and you want all of your I/O addressing to line up perfectly with an original I/O system, it may be advantageous to use the CNX 100 without those 6 extra I/O points. So you've got your choice. Either buy a base with the built-in I/O, or buy a base that's a little less expensive that does not include the built-in I/O. Okay, On the I/O module standpoint, let's start running through those. We've got the DIQ616, which is 8 in and 8 out, nice beefy half amp outputs on all of our 24 volt DC output modules, including this one, positive logic, okay? And in the case of the DIQ616, you have 2 groups of 4 outputs. And on the input side, those inputs can either be 12 volt or 24 volt levels, and they can be positive or negative logic. We also have a 4 in, 4 out module, which features relays on the output side of things. And these isolated relays can handle up to 3 amps maximum. And each relay has a completely isolated common. So all the relays are isolated from each other. So if you're mixing and matching a lot of different voltages, or you need to really separate those commons from your different relays, this could be a really good choice. Now, let's talk about, in this case, a newly available module. We now have a 16-point input-only module. This was added, a few months ago, which gives you 16 12 or 24 volt compatible positive or negative logic inputs. We've also got a relatively new 16-point DC output card. So if you've got a larger system where you've got lots of inputs and lots of outputs, it's going to be more efficient to use these 16-point input and 16-point output cards. And again, in the case of the output module, you're getting nice and beefy half amp outputs. And in the case of the DQM606, it's in 2 groups of 8. All right, a 4 relay module is available, and this one separates itself through its current rating. So this one is rated for up to 8 amps AC per relay or up to 5 amps DC per relay. Of course, you do have a maximum amount of current that's supported. You can't have an infinite amount of heat being generated from infinite current. But again, this is another one of those relay modules with isolated commons. So again, if you need to mix and match between your different voltages, or more importantly, if you want to optimize the current rating on your wiring, then this isolated feature between all the relays is definitely the way to go. Okay, one thing that's unique about OCS-I at Horner is we decided to go ahead and support an AC input module, which, most systems these days are DC, but you still run into occasionally, especially with retrofits, a requirement to have an on-off type indication for AC signals. So that's what we offer here with the DIM620. Okay, one of the more versatile modules, as well as really one of the best values in terms of analog, is our universal analog input module. Now, not only does it have great resolution, 16 bits, but it's also highly flexible. Channel by channel, you can select between 4 to 20 milliamp, 0 to 10 volts, millivolt level signals, thermocouple sensors, or RTDs. And again, this is channel by channel selectable. So if you need to mix and match a few sensors, you don't need to buy a different module for each different sensor type you're using. This one module, channel by channel, is configurable. Okay, a new module that's available is a higher density 8-channel analog input card. Still with 16 bits resolution, but now with the more common 4 to 20 milliamp and 0 to 10 volt input. So it won't do thermocouple or RTD, but it's got that high resolution for 4 to 20 milliamp and 0 to 10 volt. And if you need more density of your signals, then the ADC270 is really useful. The DAC107 is a 4-channel, 12-bit analog output card that supports 4 to 20 milliamps, 0 to 10 volts, or minus 10 to plus 10 volts, which is becoming a little harder to find these days with PLCs and remote I/O systems, but OCS-I supports it. Okay, let's take a break from talking about the modules that are available in the product line, and let's go through how do we assemble OCS-I, how do we remove the terminal blocks, how do we remove a module from the stack, all those sorts of things. Okay, here from the Horner Training Center, I'm going to show you some quick assembly of the OCS-I. All right, the first thing we need to do is gather up all these backplane connectors. Now, backplane connectors are included, 1 per box, okay, with each base and with each module. So what I'm doing here is I'm snapping them together, okay? They just snap together. All right, I currently have 3. Let me add a 4th. All right. Okay, and they're all snapped together now. Now, in terms of the orientation of this on the DIN rail, I want what we're going to call this male piece here, or this male end here after it's been assembled, to be on the left side of the DIN rail. Okay, so I'm going to go ahead and snap that into place now. Okay, just making sure everything is well seated. Okay, so I have installed my backplane on the DIN rail. And as you can see, we can slide it around a little bit to get it where we want it. And in the end, after we've installed the modules, we'll install some end stops to keep it firmly in place. But it doesn't move around quite so much after you have installed the modules. Okay, so we're going to start with the base. Remember, the base is the unit that's on the furthest left. Okay, it's always in the first position. And it's the trickiest to install, frankly, because you need to get it lined up right. It's not that difficult, but let me show you here. Okay, so what we're going to do is we're going to line up this backplane opening here with the backplane connector, and then we're going to use this feature right here as a fulcrum over the DIN rail, and then snap it down into place. All right, so let's see how we do here. Let me get this lined up approximately right. Get it up over the DIN rail, and then down and snap it home. Okay, that wasn't too bad. And then the remainder of the modules just install next to it, and they're easier to install because you can use the base or the module next to the module as a way to line it up and get it snapped into place. Okay, again, we're using the DIN rail as a fulcrum and snapping it right down. And again, physically, we're going to want to install end stops to keep it from sliding around once we're done. But basically, that's all there is to the physical installation of OCS-I. Okay, a question you might have is, well, what if I need to remove a module from the stack and it's not on the end? You know, how can I remove it? Do I have to disassemble everything? Well, the answer is definitely no. Let me show you how this works. Okay, so I've got a module that's not plugged into the rack right now. So what we're going to do is we're going to utilize this feature right here, this metal clip, I guess if you want to call it, and we're going to pull down on that metal clip for any module that's installed on the stack, and then it'll lift right out. We don't have to disassemble the backplane connectors or anything like that. So what I'm going to do, hopefully you can see this a little bit, is I'm going to install my screwdriver in the stack, and I'm going to rest the screwdriver on this metal clip, and I'm going to pull down on that clip, and then you'll see the module come right out. Okay, so I'm taking out the third module in the stack. Again, I pulled down on that metal clip. The module came right out. Then I can replace it very easily without having to disassemble anything. Okay, next I'm going to show you how to remove the removable terminal blocks from OCS-I. So I'm going to first show you with a module in my hand, just so you can see the features better. Okay, so the main feature that allows us to eject the terminal blocks is this orange pull tab, which we can put our screwdriver down through and then pull against it, okay, to cause all the terminal blocks to be ejected or to be removed. Okay, so I'm going to pull down, straight down, okay, and look what happened. All the terminal blocks have basically been ejected, and I can then remove them by hand. Okay, well, let me show you this same action, but this time I'm going to show it to you on the rack itself. Okay, you don't need to hold the module in your hand to eject the terminal blocks. Okay, again, I'm going to put my screwdriver through that orange pull tab, if you will, and then pull straight down, and then there you go. All the terminal blocks have been ejected. I can then remove them, and when I'm done, I can just, replace them by pressing them into place. Okay, now we're to the part of our program where we are previewing the products that are on their way for OCS-I. Not available quite yet, some of which you may see in a few weeks, others it may take a little bit longer. All right, let's start with the DQM602. This is our new 8-channel relay output module, which will be coming soon, and it gives you a little more density than what we offer otherwise with OCS-I. So 8 relays per module. If you need lots of relays, in your application, then the DQM602 will fill that void. The DAC207, again, higher density. That's one of the themes for the modules that are on their way. The DAC207 is an 8-channel analog output. So again, if you have lots of analog outputs in your application, this would be an attractive module for you. Still maintains 12-bit resolution, still with channel-by-channel selection between 4 to 20 milliamp and 0 to 10 volts. Now, a unique module that we really don't have anywhere else in the OCS-I product line today, and that is a single module that mixes digital inputs, digital outputs, analog inputs, and analog outputs all in the same module. So that's what the Mix 105 accomplishes with 4 DC inputs, 4 DC outputs, 24 volt positive logic. You've got 4 analog inputs and 2 analog outputs with 12-bit resolution all the way around. And this is a milliamp only analog card. So 4 to 20 milliamp or 0 to 20 milliamps only. Okay, another analog module on the way is one that will give you the ability to connect up to 8 thermistor temperature sensors to OCS-I. Okay, and these are your typical 10K ohm thermistors. Again, in applications where your thermistor is the temperature sensor of choice, maybe for environmental like HVAC or similar type applications where the low cost and adequate accuracy of a thermistor is really what you're looking for. Really a highly capable module that's on its way is our high-speed counter module. So this gives you 8 high-speed inputs and 4 high-speed outputs. The inputs are very flexible. You can use it for counting or totalizing. You can do frequency measurement, pulse width measurement. You can use it to connect to quadrature encoders. And the maximum frequency is up to 500 kilohertz, which is quite substantial. On the output side, again, very flexible with pulse train outputs, PWM outputs, as well as set point controlled outputs, maybe firing an output from an encoder position, for instance, and then also with stepper type outputs. And again, with a 500 kilohertz max output frequency this time. Okay, and then finally, a couple other big products I'm sure people will be excited to see, and that is some new CPUs will be coming probably early in 2025. A couple different models. A micro OCS based micro PLC, which we call the CPU 250, with some built-in I/O, along with the ability to expand using OCS-I on the right side of the product. We're showing 2 optional modules plugged into the side there. You could have more than that plugged in. And then on the right, we have the higher end canvas-based PLC, which doesn't feature any built-in I/O. All its I/O, locally at least, comes from OCS-I plugged into the right side, up to 7 or 8 modules, I believe. However, it has a lot higher performance being that it is canvas-based. And we have some really unique things we'll talk about when we launch this product about how could you connect a display to the CPU 300. We're doing some really innovative stuff there. I'll be excited to help the team launch this product, again, fairly early in 2025. Okay, now let's talk about our special promotion we have going on now for OCS-I. Okay, so if you use OCS-I in an application, or maybe you've already used OCS-I in an application, just fill out case study type paperwork for your application, work with our marketing team on that, and then you will win a free controller from Horner. So pretty exciting stuff. So we've got the web link shown there on the screen. Again, all you need to do is fill out case study type paperwork, tell us all about your application utilizing OCS-I, whether you've done it in the past or after you do a future application. Fill out the paperwork online and you will win a free OCS all-in-one controller. Definitely worthwhile. Okay, now in addition to today's content, there are some other OCS-I videos you should check out that are available on our YouTube channel or searchable on our website from the resources section of the HornerAutomation.com website. So we've got configuring OCS-I, that shows you all about how to configure OCS-I in Cscape. And then we have a couple other videos that talk about the universal analog input module and then goes into detail about that flexible I/O and the rest of the I/O that's built into the CNX 116 I/O base that features those 6 I/O points. Okay, we're here just about every Tuesday at 2 o'clock, whether you watch us live or on replay. If you watch us live, we have people standing by to answer your questions. If you watch us on replay, just give us those comments and questions in the comment section, and we'll get those answered just as soon as we can. Okay, lots of ways to interact with Horner online, from our website at hornerautomation.com, from our YouTube channel, as well as LinkedIn. Okay, if you are still interested in an advanced training course coming up in just a couple weeks, there are still some slots available for the November 6 to 7 advanced training course. Now, also what's exciting is Marcy has let me know that our 2025 training schedule is now posted on the website at that link you see there on the screen. So sign up early for 2025 courses. It's never too early to plan for the future. Okay, next week, our second annual Halloween special with a little bit of fun doing some pumpkin chucking. So if you want to take a break from the technical content and just enjoy a little bit of fun distraction, join us next week. Okay, that's it for this week from the Horner Training Center. Until next week, let's all get out there, automate something, and do some good.